Hello everyone. So this is a short video just to walk you through that what is the source of this two questions. So this is not the exact question in that book, a little bit different, but the function is same. But I was searching for that question. Maybe I will get some clue graphically or anything. In fact, I drew the graph of this function in Geogebra also. I will show you how this function is a kind of counterintuitive. But when I was searching, I just came to realize that I have already this book. But let's just see that whether this question or this kind of concept is given in that book or not. So that book I had, the PDF version, is the book, the name by name, Counter Example in Calculus, and the author name is Sergey Klimchuk. So you can see that exercise number 4.30 here. If you can see this thing, the same question is given. And they are saying that if a function fx is continuous on a comma b and has a local maximum at the point c belongs to ab, then it's sufficiently small neighborhood of the point x equal to c, then the function is increasing for all x less than c and decreasing for all x less than c. So this is the function we have, and it's a counter example. Why? Because of this cos 1 by x comes in the derivative, and the graph will be oscillating or the increasing decreasing in very small interval also. We can analyze this thing by usual method like f dash x we see here, and cos 1 by x as a derivative we got, and after that. So but it's a very good to notice that this question came from this book. When I was searching this question, I also came just at top of that. There is one question you can see here. By the way, these are solutions here. You can see this is the question here, the counter example. So the question they have framed before, and then after that they are giving the solution. Means he is giving the solution, the author. So if both functions fx and gx are differentiable on R, then evaluate the limit this thing. And after that they are saying this is a counter example. In a counter example, they've given 6x plus sine x by 2x plus sine x. The same function we had also, but not the limit and all, because our function in the question was the same function 6x plus sine x by 2x plus sine x, but the function is different because it's defined on x equal to 0 and they're asking different thing. You can see that this book, let me just show you my OneDrive Vault, and you can see I have this many books. You can see in calculus, the math textbook, you can see that. So for math textbook, I have calculus, and that calculus, this is the counter example in calculus, infinite series, and all these books I have. So when I was searching in this all books, I came up with this thing. So it's a by luck because there are many books I have, but why I searched only 2 or 3, and then I came to know that this come from here. All right. So now I'm going to show you how the this graph can be drawn in GeoGebra, and we can see that how it behaves. So especially this question number this thing 3. So here we are in the GeoGebra, and the question we have 2 minus 2x square. So 2 minus 2x square and minus x squared sine 1 by x. So you can see that there is no such problem that to find out the maximum value here. But why all this situation is happening is a little bit difficult. So you can see at the very top, it's not hard to see that at 0 the maximum value is 2 only. But in the neighborhood, as I can zoom in the graph, you can see that the oscillation is happening. So there is no such interval around 2 you can find, so that you can clearly say that the function is only increasing or the only decreasing, either on the right to the y-axis or left to the y-axis. So this was my take on these two questions. So I'm lucky that I found this two questions in this book and I could show you. So there's a good book, actually you can read it. But I have not read it in recent 1 or maybe 6 months. I don't know how I came up with that. So this is a very good book. You can read it, and I think it's from where I downloaded, I don't know, because I downloaded very long back, but I think it is available on this internet. And one more thing I wanted to show you, that this question, by the way, this solution is actually okay now, everyone can solve. Maybe in future I will create a video on that, how to solve it. I have come up with that, and after that I realized that it's easy, and I just jumped into the Geogebra to see this graph, and then I came up with this book thing. And this question also, I think that we can do in this way also. Why we are drawing the graph of this, what we call, let me just show you. Yes, we are drawing the graph of cos x, means we are analyzing the graph of tan x, x and cos x together. We can also draw the graph of this, and how we can draw it, let me just show you quickly. If we differentiate, we got x sin x, and by using these two things we can simply draw the graph, because at 0 the value of the function is 0, so it will start from here, and the g dash x is also 0, so it will start from here, and at pi by 2 what will happen, at pi by 2 this value is derivative is positive, but at pi by 2 this value is 1, so at pi by 2 it should cross 1, so this is, let's say, pi by 2, it will cross 1, and after that you can see that pi, at pi this value will become 0. It means at pi this function, this gx function will attain its maximum, because it has to increase, and after that it will come down, and again at 2 pi it will takes its negative, I mean the minima. So in that way we can find that from, I did a mistake, I believe, no. Yeah, that's correct. This is actually 2 pi. It will attain its minima, and minimum value is actually what? At, you can substitute 2 pi there, so sine 2 pi is 0. It becomes minus 2 pi. So this will hit a very long down, and this value was pi actually. So you can see that between pi and 2 pi there is a one like one time it is crossing the x-axis. So the gx is crossing the x-axis one time. It simply means that it is coming from positive to negative. So from pi to 2 pi, the original function fx would have local maxima for the original function, and from there again we can continue this graph, and we can analyze the graph of g dash, means the f dash x only, that is gx, and we can tell about the fx. In another video I will try to explain it in a better way. Just it was to show you that from where these two questions have been taken. So that's all for today. Stay math active.